For decades, comets have been nothing more than spectacular visitors, icy remnants from the dawn of the solar system, briefly lighting up our skies before disappearing into the darkness again. But now, something far more unusual is unfolding. NASA's Deep Space Tracking Network has just confirmed that 7 comets, not 1 or 2, but 7, are currently on inbound trajectories toward the inner solar system. Among them is one that doesn't belong here at all. A mysterious interstellar object named 3I Atlas traveling from beyond the Sun's gravitational reach, and it's not alone anymore. For scientists, this is more than a rare celestial event. It's a once-in-a-century convergent and possibly a new window into how our solar system formed, how it evolves, and how it could one day be threatened. Every year, a few comets drift inward from the outer solar system, often faint, short-lived, and barely visible without telescopes. But 2025 is different. Astronomers at observatories around the world, from Mount Aya in Hawaii to the European Southern Observatory in Chile, are now tracking an unprecedented swarm of 7 comets, all set to enter the inner solar system within a matter of months. It's a phenomenon that hasn't occurred in modern history. The last time anything remotely similar happened was over a century ago, and even then, the scale was smaller. This time, the swarm includes icy bodies from the Kuiper Belt, long-period comets from the Oort cloud, and even one with an interstellar origin, a combination never observed before. The odds of this happening simultaneously are astronomically low. Each comet on its own would already be an object of scientific interest, but together they offer an extraordinary opportunity, a chance to study the behavior, composition, and evolution of some of the oldest material in the solar system. Material that has remained unchanged since before the planets even existed. In total, 7 distinct comets are now confirmed to be inbound toward the inner solar system, each with its own story, its own origin, and its own scientific significance. Together, they represent a living timeline of our cosmic past. 1C 2025A1SW, the first arrival. The earliest to arrive will be Comet C 2025A1, known as SSW, discovered by NASA's Solar-and Heliospheric Observatory. Estimated to pass perihelion in late March 2025, SWAN originates from the Oort cloud, a spherical shell of icy debris nearly a light-year from the Sun. Its long elliptical orbit suggests it has not visited the inner solar system in millions of years. Scientists believe its volatile composition, a mix of frozen water, carbon monoxide, and complex organic molecules, could offer a direct glimpse into the primordial material from which the solar system formed. 2C20-25, B3 Yoshida Therapid Diver. Following close behind is Comet Yoshida, set to make its closest solar approach in early May 2025. Unlike SWAN, Yoshida's trajectory will take it on a steep, high-inclination orbit that dives sharply toward the Sun before slingshotting back into the depths of space. Its orbital period exceeds 10,000 years, meaning humanity has never seen it before and may never see it again. Astronomers are particularly interested in its rapid acceleration near perihelion, which could reveal how comets respond dynamically to intense solar heating. 3C 2025F2 Helios, the Sun Grosser. One of the most dramatic of the group, Comet Helios, will pass dangerously close to the Sun within just 0.05 astronomical units in late June 2025. Classified as a sun grazer, Helios will experience temperatures high enough to sublimate surface ices almost instantly. Scientists hope to capture rare observations of how the Sun's intense radiation and magnetic fields interact with a comet's nucleus. If Helios survives its fiery encounter, it could produce a tail visible even in daylight. EC 25K1 Artemis, the split core. Discovered only months ago, Comet Artemis appears to be a fragment of a larger parent body that split thousands of years ago. Its double-lobed nucleus and irregular dust jets make it a perfect target for spectroscopic study. Artemis will pass perihelion in August 2025, likely forming one of the most photogenic tails of the year. 5C 2022-504, Magnus, the massive traveler, the largest of the inbound group. Comet Magnus boasts a nucleus estimated to be more than 30 kilometers wide, roughly the size of Manhattan Island. Its highly eccentric orbit will bring it within 0.9 astronomical units of Earth in September 2025, making it a potential naked eye object. Its sheer size and brightness will offer astronomers an unparalleled opportunity to study outgassing processes and tail formation in real time. 6C 2025P5 Icarus. The close pass comet Icarus will pass closest to Earth within just 18 AU in October 2025. While not a collision risk, its proximity means it will be closely monitored for potential dust and plasma interactions with Earth's magnetosphere. Its composition also suggests it may be a transition object, Hart asteroid, Hart comet, blurring the boundary between the two categories. 7. 3I Atlas, the interstellar intruder. And finally, the most enigmatic of them all, 3I Atlas. Unlike the others, this object does not belong to our solar system. Its hyperbolic orbit with a velocity far exceeding the Sun's escape speed confirms that it originated beyond our stellar neighborhood. Atlas is enormous. Its coma could expand to more than 700,000 km across, dwarfing Jupiter. Its composition may contain isotopic ratios never before measured, offering clues about the chemistry of other star systems. What concerns scientists most, however, is its unpredictability. Its non-gravitational acceleration and unusual light curve suggest that it may be venting material in ways unlike any comet we've ever studied. Comets are far more than beautiful streaks in the night sky. They are time capsules, frozen relics from the earliest days of the solar system. And every time they approach the Sun, they become natural laboratories for physics, chemistry, and space weather science. At their core, comets are conglomerates of dust, rock, water, ice, and frozen gases. As they near the Sun, intense solar radiation causes these ices to sublimate directly into gas, forming the bright coma, a thin, glowing atmosphere around the nucleus. Solar radiation pressure and the solar wind, a continuous flow of charged particles from the Sun, then sweep this material into tails that can stretch millions of kilometers into space. These tails are more than just visual spectacles. The ion tail, composed of charged gas, traces the shape of the interplanetary magnetic field, providing scientists with real-time data about solar wind conditions. Meanwhile, the dust tail records the size distribution of ejected particles, revealing how a comet's nucleus evolves over time. But there's another more dramatic interaction that researchers are eager to study: magnetic disconnection events. Occasionally, a powerful solar storm, such as a coronal mass ejection, slams into a comet's plasma tail, severing it entirely. This sudden snapping is a spectacular demonstration of space weather physics, and the 2025 swarm provides a rare chance to observe it across multiple comets simultaneously. Studying these interactions isn't just an academic exercise. The way comets respond to solar radiation and magnetic turbulence mirrors how Earth's magnetosphere behaves during solar storms. Data collected from these encounters can improve space weather forecasting, crucial for protecting satellites, power grids, and astronauts in orbit. For astronomers, both professional and amateur, the coming year will be a once-in-a-lifetime opportunity. It's rare enough to witness a single bright comet crossing the inner solar system. But to observe 7 in a single year, each with distinct characteristics and behavior, is virtually unprecedented in modern astronomy. Here's how you can experience this historic event for yourself. When and where to look. Most of the comets will become visible between March and October 2025. But their brightness, timing, and position in the sky will vary. Swan, March-April, best seen in the pre-dawn hours of late March in the eastern sky. A good pair of binoculars or a small telescope will reveal its faint greenish coma. Yoshida may look for it in the northern hemisphere just before sunrise. Its steep inclination means it will appear briefly but brilliantly before vanishing back into the darkness. Helios, June. This sungrazer may become visible even in daylight near perihelion Tho. Extreme caution is required when observing near the Sun. Specialized solar filters and indirect imaging methods are essential. Artemis and Magnus, August-September, both are likely to develop long spectacular tails visible to the naked eye. Observers in mid-latitudes should look to the western sky after sunset. Icarus, October. Its close approach to Earth means it could become one of the brightest objects of the year, possibly even brighter than Venus. A simple set of binoculars will reveal fine detail in its structure. 3-Eye Atlas throughout 2025. As the most mysterious of the group, Atlas will remain under close observation. Its unpredictable activity means brightness-y estimates could change dramatically, potentially producing a stunning display visible to observers worldwide. For beast results, astronomers recommend dark skies far from city lights, a pair of 10x50 binoculars, or a moderate 4 to 8-in telescope. And for those who want to capture images, long-exposure astrophotography will reveal stunning detail in tails, jets, and coma structure, far beyond what the human eye can see. Final thoughts. For centuries, humanity has watched comets with awe and wonder, sometimes with fear. Ancient civilizations saw them as omens. Modern science sees them as time travelers, travelers carrying the secrets of our cosmic origins. And in 2025, as 7-SE messengers sweep through our celestial neighborhood, one from beyond our solar system entirely, we are reminded that we are part